Hi, we were seeing about linear algebra. Let us have a quick recall of what we saw so far. We saw about the vectors, spaces, and we defined the two basic operations, scalar multiplication and vector addition. What do you mean by scalar multiplication? It is either shrinking or stretching the vector. This is what is the meaning of scalar multiplication. These are we have seen. Then we saw the system meaning of a x equal to y and a x equal to 0. Correct? I am writing this as theta because it's a vector full of zeros. What does this mean? This represents a system. Correct? What does this mean? This represents a system in which x is the input, y is the output of the system. Correct? This is what we understood. And ax equal to theta means what? I have a collection of non-zero x, which when I apply to the system, I always get output as 0. I am interested in finding non-zero x, which will give 0 output. See, x equal to 0 will definitely give 0 output. So this is called the trivial solution. This I know. This is a trivial solution. Means I know this solution even before solving the problem. If such a problem is given before solving the problem, I know that. Whereas I am interested in finding the non-trivial solution. Non-trivial solution means what? X not equal to 0, still ax equal to 0. First we should know such a solution exists or not. So we proved that if non-trivial solution should exist, the condition is determinant A should be 0. Determinant A should be, that is, A should have dependent columns which will make determinant A as 0. Let us solve a quick example to understand this. Okay. So let us say the system A is given by 4, 3, 2, mu. Okay. X is equal to x1, x2. Find the condition on mu such that ax equal to 0 will have a non-trivial solution. Okay. So this is a system of equation. We have to find the non-trivial solution. Find the condition on mu such that ax equal to 0 will have a non-trivial solution. So what do we know? For non-trivial solution to exist, what is the condition? It should be 0. That is, the system matrix should be a singular matrix. Correct? Determinant A is 0 means system matrix should be a singular matrix. So what is determinant A? Determinant A is 4 mu minus 6, or mu should be equal, this should be equal to 0, or mu should be equal to 6 by 4. This is nothing but 3 by 2. Correct? So if mu is 3 by 2, I will have determinant A equal to 0. So mu is equal to 3 by 2 is the required solution. Now let us go ahead and see what happens when mu is 3 by 2. I will have 4, 2, 3, 3 by 2. Correct? Observe that I can reconstruct this column I can reconstruct this column from this column. How? By multiplying 4 by 3. If I multiply 4 by 3 to the second column, it will give me the same first column only. Correct? What is 4 by 3 into 3? It is nothing but 4. What is 4 by 3 into 3 by 2? This is nothing but 2. Correct? Which is nothing but 4, 2, which is nothing but the first column. So the system is having that if I can reconstruct a column from other column, it is said to be dependent. So if I have dependency in column, then only I can have non-trivial solution. So this dependency will make the system output go 0 even though x is not 0. Clear? This is what we mean by the dependency in the system. Clear? Okay. Now let us see the system Ax equal to y. This is more interesting case. Now Ax equal to y means what? I have a system. Okay. I apply an input x and I get the output y. Okay. Fine. Now, whether this y is attainable or not is the question. Okay. Y is attainable or not is the question. Okay. Is y attainable can we get y by applying some x is the question. See, I know the system, I know what I want. Say for example, understand it this way. There is a system, I know that this is the desired output. I know this is the desired output of the system. I am interested in knowing what input I should apply for me to get that output. Correct? Say for example, I can even take this class as a system. See, the desired outcome of this class is what? That all of you should clear gate successfully. So that is the desired outcome. The class going here is the system. So as a student, what inputs you take from this class or from the corresponding classes and apply to yourself to get the required results in gate. This itself is a problem in linear algebra. It might be funny, but it is true. Now the question is, can we get y by applying some x? Means what? Okay, let me explain this with an analogy. Say that for example, you are here. Okay, I am here. I am having a gun. Okay, I am not teaching you terrorism. I am just giving an example. I have a gun whose range is 100 meters. Okay, I am here. Okay, and this is my target. This is my target. Okay, the range of the gun is 100 meters. Okay, this target. Now, the input is what? The shooting angle. I can shoot like this. I can shoot like this. I can shoot straight. Different shooting angles are possible. I have a gun with different angles. I hit different regions in the target. Correct? Correct? Yes or no? I shoot different regions in the target by varying the shooting angle. Correct? So I have a set of shooting angles for which I get a set of points on the target. Correct? Yes or no? This is true only if this is within 100 meters. Correct? If this is less than or equal to 100 meters only, it is possible. Say for example, you are here. I have a target here whose distance is greater than 100 meter and I am varying my shooting angle. How much ever I shoot, I will be landing here only. Whatever way I shoot, I will be landing and I cannot hit anywhere. I cannot hit the target at all. Correct? So whatever input I apply, whatever may be the shooting angle or the shooting accuracy I keep, I can never hit the target. Correct? So for any x, for any input here, for any input in the second case, for any input, I cannot hit the target. Correct? I cannot hit the target. Clear? For any input. Say that is what the question I am asking here. Can we get y by applying some x? There is no guarantee that you will get this y by applying some x. It might be like the case 1 where you can apply x. For example, this is the target you want to hit. I apply this shooting angle. My gun, at the gun, the bullet goes and hits here. So there exists a x which will get me that y. Whereas in this case, no x exists with the given system which will take me to the y. Correct? So, first the moment the system is given ax equal to y is given, the first question we ask is whether the system is solvable. Is this system solvable? This is the first question we ask. Does this set of equation, is this solvable? Means what? Does this have a solution? The question I am asking is the system consistent? That is what I am asking. Is the system consistent? Whether it has a solution or not. Okay? Yes? No. If there is no, then no solution exists. Correct? No value of x will take you to that value of y, means no solution exists. If it is yes, then again we need to ask one more question. Is it a unique solution or a system of solution? How is the solution? Okay, we need to check how many solutions exist. How many solutions? That is one or infinite. See, for example, let me take you to the gun problem itself. Say for example, I want, you are here, okay, you are here, this is the target, okay. Now you are having a gun, okay. Now the input is the shooting angle and shooting position. These are the input. That is, position means at what point, whether you are standing and shooting, whether you are jumping and shooting, you are bending your body and shooting. That is one thing. And shooting angle is with respect to the ground, what angle is the gun making. Okay, that is what is the shooting angle and shooting position. Now, say for example, to hit this point, the point is such that only from one position you can hit this point. Okay, only from one position you can hit this point, or there might be some point here such that you can hit this point in a multiple ways. Whether I can stand and shoot, I can stand and shoot with zero angle, or I can bend my body and shoot that, I can still hit that point by making 20 degrees angle, or I can jump and shoot down and still reach the same point. Different ways are possible to reach this point. That is the nature of this point. Whereas to hit this point, I have to stand and make 20 degrees with the ground. Then only I will hit the point. That is the case here. So there is only one possible solution, or whether there is infinite solution exist. Okay. So I need to answer these questions. Okay. How many solutions exist? So I need to answer this question, and I need to answer this question, whether the system is consistent or not. So I need to establish conditions for consistency and checking the number of solutions of the system. If the system is inconsistent, there is no point in solving the system because no solution exists for the system. Clear? So I need to answer all these questions before finding the solution. So how do I answer that question? So we were talking about the system of Ax equal to y, and we were talking about consistent. Correct? Yes, no, then if the system is consistent, I need to ask how many solutions, and I need to find one or many. No solution means if the system is not consistent, then no solution exists. This is the flow chart for solving this type of problem. This is the decision we make step by step. So first I need to understand the consistency of the system. For that, I will go again and form a matrix called AY. This is called the augmented matrix. Okay. I form augmented matrix. I simply attach the Y to A and form a new matrix called AY, called the augmented matrix. Now, if rank of A equal to rank of AY, then the system is said to be consistent. This is the consistency condition what I am talking here. If rank of A is equal to rank of the augmented matrix, then the system is consistent. Then if rank of A is equal to rank of AY and it is equal to number of unknowns in the system, then only one solution will exist. One solution exists. If rank of A equal to rank of AY, but this value of rank is less than number of unknowns in the system, number of unknowns in the system, then many solution exist. Or to be specific, many solution exist. Or to be specific, I can say infinite solution will exist. Okay. If rank of A not equal to rank of AY, then no solution exists. So the first thing for me is to find this rank of what is the rank of the system matrix and what is the rank of the augmented matrix, and if they are same, then a solution will exist. If they are not same, the problem ends there itself because no solution exists. This is what we are going to deal in the system of equations from now on. Now, find the condition on lambda for the system to have A, B, C. Unique solution, no solution, infinite solution. How do we proceed now? This is the problem. Find the condition on lambda for the system to have part A unique solution, part B no solution, part C infinite solutions. Now what does this mean? That means the system matrix is what here? 2, 3, 5, 7, minus 3, minus 2, 2, 3, lambda, x, y, z is equal to 9, 8, 9. This is the system matrix. So what is the first thing? This is of the equation of the type Ax equal to y. So the first thing I need to do is to form the augmented matrix. 2, 3, 5, 9, 8, 9, 7. That's 2, 2, 3, lambda. Now, what is the condition for the system to have unique solution, no solution and infinite solution? This is the question asked. So how do we proceed? How do we proceed? The first thing we need to find is rank of A. For part A, if unique solution means what? Unique solution means what? Rank of A is equal to rank of AY, and this is equal to number of unknowns. Correct? No solution means what? Rank of A is not equal to rank of AY. Correct? Yes or no? Correct? Then what will happen here? What will happen here? What will happen? Okay, let us see what happens. Say for example, let me say for example, R1 equal to R1 minus R3. This is the system AY, right? This is the augmented matrix AY. What will happen here? If I do R1 equal to R1 minus R3, what I will get? I will get 2 minus 2, 0, 3 minus 3, 0, 5 minus mu, 9 minus 9 will be 0, 7, 3 minus 2, 8, 2, 3, lambda, 9. Correct? 2, 3, lambda, 9. Okay. Now what is the meaning of this? What is the meaning? Now, if mu equals 5, what will happen? If mu equals 5, what will happen? If mu equal to 5, what will happen? If mu equal to 5, what will happen? I will get 0, 0, 0, 0, 7, 3 minus 2, 8, 2, 5 minus lambda I will get, right? 5 minus lambda I will get. If lambda equal to 5, what will happen? Lambda 2, 3, 5, 9. This is what I will get, right? If lambda equal to 5, I will get like this. Then what is rank of A? Rank of A will be what? Rank of A is what? Rank of A, because A, this is A. A contains a row full of zeros. So rank of A cannot be 3. So if I see this is a 2 cross 2 determinant within A, which is having non-zero determinant. So rank of A is 2. Correct? What is rank of AY? What is rank of AY? Rank of AY will be what will be rank of AY? If rank of AY will be again, I can pick anything. If I pick this entry is also 0. So if I try to pick any 3 cross 3 determinant, it will have a row full of zeros. So rank of AY will also be only 2. Correct. So rank of A equal to rank of AY equal to 2, but it is less than 3. What is 3? Number of unknowns in the system. Unknowns in system. Correct? Yes or no? So rank of A equal to rank of AY will satisfy the consistency, but it is less than the number of unknowns in the system. So lambda equal to 5 will make the system have infinite solutions. So I have solved part C. This is the lambda equal to, this is the answer for part C. Correct. I have infinite solutions. Correct. Infinite solution means what? Infinite solution means what? Rank of A equal to rank of AY, but this is less than number of unknowns in the system. Correct. So I have found the condition on lambda. If lambda equal to 5, I will have this. If lambda not equal to 5, what would have happened? If lambda not equal to 5, what would have happened? What would have happened? I would have, say lambda is not equal to 5, say lambda equal to, say for example lambda equal to 6. For example, lambda is not 5. Lambda is any other value than 5. Say lambda is 6. What will happen? 0, 0, minus 1, 7, 3, minus 2, 2, 3, 6, 0, 8, 9. What is rank of A? Rank of A is now 3. Rank of A is 3. Rank of AY is also 3. So lambda not equal to 5, and this is equal to number of unknowns. So lambda not equal to 5 will give unique solution. Any value of lambda not equal to 5 will give a unique solution. And here we also observe that for any value of lambda other than 5, I will get unique solution. For lambda equal to 5, I will get infinite solution. That means for any value of lambda, I have a solution. So there is no value of lambda such that I get no solution. So part B, so the answer for unique solution is lambda is not equal to 5. The infinite solution is lambda equal to 5, and no lambda exists. No lambda exists. I don't have a lambda for which I get a no solution. That is, the system will have always, it will have a solution for every value of lambda. This is how we solve these type of problems. Clear?